Hey, hello there. So I'm gonna talk about today's Leetcoding challenge question real quickly. It's a fairly easy one. It's called number complement. So we have a positive integer and we want to return its complement number. The complement is done by flipping the bits in the binary representation. So for decimal number 5, so it's 4 plus 1. The binary representation is 1 bit in the 4th position and 1 bit in the 1's position. So that's 4 plus 1, we get 5. So the binary representation is 1, 0, 1. If we flip the bits, we change 1 to 0, change 0 to 1, we get 0, 1, 0. So that's 1 bit in the 2's location, the result is 2. So that's the example. Second example, we have 1, flip the bits, we get 0. Here's some notes here. The length of the integer, it's 32-bit signed integer, so the maximum is 2 to the 31 and minus 1. So we effectively have 31, I guess 31 or 31 possible locations for the possible bits in the number, so that's just the amount of work, maximum number of work we need to do. So the time complexity for this question is order of 31, which is pretty much constant, and we can assume there's no leading 0 bits in the integer's binary representation, so we don't have to pad ones all the way towards the towards the left to make the binary representation to be in the full length. So that's something we don't need to do. And this question is same as 1009, which is essentially right, but that question is dealing with non-negative case, non-negative numbers, so you have to handle 0, but this one is strictly positive. Yeah, so that's pretty much the question. There are a couple of things involved in solving this. One is how we actually flip the bits. The bit flipping is one of the ways to do it is by exclusive alls. So let's just let's just show the truth table between 2 bits A and B. We're gonna show you the I'm gonna show the truth table for this thing. If both are 1, the exclusive all gives us 0. If both are 0, it's also a 0. If we have 1, 0, we get a 1, and if it's 0 and 1, we get another 1. So let's rearrange this a little bit. So when you're just looking at the very first line, the A here is always 1. The the binary for B is 1 or 0. By doing exclusive all, the result is the opposite for compared to B. So to flip a bit, we can just do by doing exclusive all with a 1 bit, we get the complement of B. So that's how we get this. For a number with multiple bits, we can just apply this flipping bit by bit from rightmost towards leftmost, or the leftmost towards rightmost, whichever it's more convenient. So let's look at the number 100 or 1011. So we can just have a 1 bit here. So doing exclusive all, we can flip that very last bit. We can get 1010, and the next iteration we're gonna shift the 1 bit towards left by another position. So that's so let's do left shift by 1. So that's effectively making it into 1 0. So load it up there. 1 left shift by 1, we get 1 0. So that's what this is here. So now this is the result from flipping the last 1 bit there. Then we flip the second to the rightmost bit, we change this to 1000. So yeah, that's pretty much the strategy. We're going to looping through the number here from the rightmost bit towards the leftmost 1 bit, and just flip the bit, one at a time. So the maximum number of operations we need to do is, big O of 31. That's the number of possible 1 bits in here. Because the very first bit is used for sign, so that bit we don't need to do anything. How do we determine the number of bits we need to do? We can derive that by applying right shift for this number. So let's say that we have number 1011. So if we shift this towards right by 4, by 1, we get 101. We shift that towards right by 1, we get 10. Again, we get 1. Then in the end, we get 0. So there are 1, 2, 3, 4. 4 times we can apply the right shift. So we can just need to shift the 1 bit towards left consecutively by 4 times. 0, 1, 2, 3. And just flip the bit at that location, and we are done. So that's pretty much it. We can also make a mask with all the ones. Instead of doing bit by bit, we can also do 1, 1, 1, 1, and just directly apply exclusive OR between these two numbers, which should be fine. It's equivalent to do this bit by bit, but you still have to generate this number. One way to do that is to have 1000. That's just a 1 bit more, with only 1 bit there, and all the rest to be 0. We subtract the 1, we can get to this number. But the problem with this is, first thing, you still have to determine how many bits are there. So the number of shifting right shift you need to do to get that length, it's fixed in there. So another question is, we don't want this. This can potentially lead to overflow, because you need a 10000 thing that's 1 length longer than the input number. So that can potentially lead to overflow if you're not dealing with it carefully. So for that reason, I'm just gonna flip the bit in the loop while we count the number of bits the input number has. So that way we don't run into the risk of doing overflows. So that's quite too much of analysis for this simple question. So yeah, my test there was unsuccessful, but I think I can get the code working in one shot. So I'm just gonna create a variable called number complement, which is the number itself. Make a copy, and we're gonna flip the bits in this number, and we're gonna use the origin number to do the right shift to tell us when we're gonna terminate. So we're gonna use a for loop. The initial location where we apply the bit flipping is the 0th location from the right, and while the number is still greater than 0, not 0, meaning that we haven't right shifted all the bits, all the 1 bits, we can continue apply right shift. That also means we can still we should apply more bit flipping, and after the iteration, we're gonna shift the number towards right by 1, and we're gonna increment the location that we apply we move the 1 bit towards left and do the actual flipping. So inside the body is just the exclusive OR between the number of complement, the number and the 1 bit, applying left shift to the amount. So that's pretty much it. Let me actually just submit. I think it should work. No? Oh. case. So in here I'm updating the value, so that's assignment, but here, yeah, it's just a shifting. This time it should work. Yeah. So that's pretty much this question here. Only one thing you need to change to make this code the code work for this 1009 question is just out of one line. If the number is 0, we just return 1, and that should handle that. So by adding this one line here, we solved that question as well. So yeah, that's the question for today. It's quite straightforward bit manipulation question, but I guess if you forgot about bit, you could still work with it, right? You can have you can basically just treat this as a string and have a loop over and just change it 0 to 1, 1 to 0, and cast that back to integer, and that should work as well. Yeah, so that's the question for today.